When you think about what you do as a developer, certainly querying and manipulating data has always been a fundamental part of what you do. The data formats change over the years. I've been doing this for 25 years, and things have changed, but the core needs are always the same. If you think back to 1985 or so, back when we used DBase as the language for querying data, you might have seen a query like this. That is, a language, DBase was a language, which allowed you to specify queries directly in the language itself. Of course, there was no IntelliSense or compilers back then for this sort of thing, but you still can see that the language itself defined the type of query that you might create. Moving ahead to the world of .NET, you might see code like this when .NET first came out. Now you notice in here that any command text you want to write is just a string, so that it's up to you to make sure that the syntax is correct. In addition, working with parameters, it's just strings. You create a connection, you open the connection, you execute a command, and then you iterate through the data that comes back. And certainly, this technique worked, and it was very familiar for those coming in from earlier non-managed data access techniques. Now, over the last few years, previous to the current years that is, object relational mapping has become a feature of various tools. Now in C# you might see code like this that allows you to express a map between data and code. That is, you create a class, in this case maybe named employee, and this class then gets filled in with data somehow or other, maybe magically, and your code then just iterates through instances of this class rather than dealing with the data directly. This abstraction distances you from the structure of the data, so should the schema change, your code might not have to change, and this is a benefit. This object relational mapping provides for a mapping between relational data to and from objects. That means that you use your instances of classes to get the data from the database, make your changes, and then some sort of magic layer shoves the data back out to the database. It provides a cleaner integration of business rules and validation. And so this technique using an object relational mapping, that's kind of the concept behind the typed data set in .NET, has become very popular. But challenges still remain. How do you retrieve non-relational data? Maybe you want to work with XML data or data coming from an RSS feed, data retrieved from a web service or a REST service, Active Directory. Maybe you have to interact with files in the file system or other non-relational data. Well, object relational mapping really isn't meant for that sort of behavior. And what if you want to interact with plain old objects? Maybe you have a collection of some sort of object and you'd like some general way to iterate through or search for instances of objects with certain properties set. How do you interact and query custom domain models that don't have a mapping to some database? How do you enable clean code, that is, code that works easily and is maintainable, in both a strongly typed and a dynamic language world? As time goes on, languages are moving more to a dynamic model. The answer, for now, is LINQ, that is, Language Integrated Query. This provides query, set, and transform operations for .NET built right into the language. It makes querying data a core programming concept, part of the language itself. And it works with all types and shapes of data. It works with relational databases. That's where you're most likely to use it, but it works in other situations as well, and we'll actually start with other situations. It works with XML. There is a version of LINQ that talks directly with XML data. And you can use LINQ to query just plain old collections of objects. It provides an exciting new way to retrieve data about objects that you might have otherwise written iterative code to work out. LINQ works with all .NET languages, and VB and C# have integrated language support, meaning the LINQ methods are sometimes wrapped up in language keywords. You can always get to the LINQ methods, but VB and C# have special integrated language support. It works with both Windows and web applications. And you can also find third-party link providers. Amazon.com, for example, has written a link provider so you can use LINQ over Amazon.com's data directly. Now let's think about how LINQ and languages interact together. LINQ and languages allow you to write your data access code directly. You get compile time, syntax, and schema checking, and you get IntelliSense too against the schema of your data. There's no need to create a query as a string, then wait until runtime to see if it includes the correct field names and the correct syntax. Instead, the LINQ data access code is abstracted from the underlying data. You get a consistent syntax across all different data sources. LINQ looks like LINQ no matter where you use it, and you can join information from different sources. Basically, LINQ makes it much easier for you to create queries in your code. In order for LINQ to work with languages and their built-in features, there are some required language changes. We'll look at all of these as we work through LINQ examples. First of all, query expressions. We need some way to define the query and what data it should retrieve. Anonymous types allow you to define a type inline in the query, because sometimes you have no reason or cannot create ahead of time a type that defines the data you want to retrieve. Extension methods allow you to extend an existing class in the .NET framework even if you can't inherit from that class, if the class is sealed. Lambda expressions are, well, to C# developers, like little anonymous methods. To Visual Basic developers, this is a brand new concept, that you have a method that you describe in line in your query. We'll see examples of this later on. Implicitly typed local variables. This is great for queries because it means you don't have to specify the type of a return type of a query, because often you won't know. There's no way to know ahead of time what data type your query returns. But it also means that in general code, you can often get away with not specifying the type of a variable and allow the compiler to do it. It sounds like this is an evil thing, but actually it saves you from some typing when it's obvious by looking at the code what the data type is going to be anyway. Object initializers allow you to specify the initial values of properties of objects even if the constructor for that object doesn't allow you to specify any values. It's a great way to set the value of properties of objects for any object. It's required for LINQ, but it's useful elsewhere as well. Visual Basic and C# both add all these language features, and each of them has a few tricks of their own up their sleeves as well. Now, there are a number of different ways to use LINQ. You can use LINQ to objects. This allows you to iterate over any collection that implements IEnumerable and retrieve data easily, so you don't have to write code that actually loops through the objects looking for things. LINQ will do that for you. It makes any collection of objects a data source. I love this feature and use it often because it really simplifies code. We'll see a few examples of that. We can use LINQ to relational data. For example, LINQ to dataset. There's also LINQ to entities. We won't cover that in this course because we're focusing on core language features in this course. There's also LINQ to SQL, which allows us to query SQL Server data. There's also LINQ to XML, which makes a better XML DOM. That is, it's a replacement or an addition to the XML document object model. To finish up our overview, let's take a look at a graphic representation. Now, if you think about the LINQ-enabled data sources, we have LINQ to objects, which communicates with objects. We have LINQ-enabled ADO.NET, which talks to datasets, to SQL, or to entities. And we have LINQ to XML, which works with XML data. Now, above that, we have .NET Language Integrated Query, which is the language layer which allows Visual Basic, C#, and other languages to communicate directly with those LINQ-enabled data sources. Well, enough talking about it. Let's actually dig in and look at some of the syntax. The general format of a LINQ query looks something like this. We start with the from statement. Every query has a from statement specifying where we're getting the data from. You can have a where clause indicating some criteria on that data, an order by clause indicating how you want to order the data, and you'll end with a select statement which indicates what subset of fields you'd like to retrieve, or maybe all of them. Why is that select clause last? Well, think about it. There has to be some way for IntelliSense to know, as you're typing, what fields you could possibly choose when you say select field name at the end. Well, if you didn't have it last, there'd be no way for the IntelliSense to know that. So to make it easier for you to type these LINQ queries, the designers of LINQ decided to put the select clause at the end. If the select clause appeared at the beginning of the query, there would be no way to determine the data source for the IntelliSense and to list for you the appropriate fields. So a simple query might look something like this. Imagine you have an array of integers. In this case, 1, 5, 3, 6, and so on, named numbers. Now I'd like to retrieve from that array a separate data structure with a list of numbers that are in that array that are odd in descending order. Well, there's lots of ways I could do that, but notice how LINQ lets you do it. We declare a variable, odd numbers, using the new keyword var, which doesn't require you to specify the data type. It allows the compiler to implicitly infer the data type from the LINQ query. Here we have a from statement which says from number in numbers. What does that mean, number? What is number? It's an iterating variable. It acts as an iterator that loops through all the values in numbers. You have to specify a name for that so you can refer to it in other clauses. Here, where number modulus 2 does not equal 0 will give us the odd values. Order by number descending, well, that orders by the number in descending order. Finally, the select statement, which says what value you want to retrieve, and in this case, it's just that value number. Let's run the demonstration and convince ourselves that it works. I've loaded the sample project LINQ demo, and I'm running the project. I pressed F5 so I can debug. I also have breakpoints set in each of the procedures that these buttons call so we can single step through the code. I'll select the first example, and this brings up the same thing you saw on the slides previously. This starts by creating an array of integers named numbers, and it contains the numbers 1, 5, 3, 6, 10, 12, and 8. What I'd like to do is retrieve a list of the odd numbers in that array in descending order. So I'll do that by creating a variable odd numbers. Now notice, I don't have to declare the type of odd numbers. As a matter of fact, I don't know the type of odd numbers. It turns out that it actually is a system.link.ordered enumerable value, but I have no way to know that. At compile time, I'd have to reverse engineer what the compiler is doing to determine what the type is. So with LINQ queries, you're best off using the var keyword to declare your variables that contain the query results. Odd numbers is that variable. I've declared it using the var keyword, and the syntax for the LINQ query is from number. Now number is our iterating variable that will iterate through whatever I tell it to iterate through. In that case, that is in numbers, our array of numbers, where number modulus 2 does not equal 0. That should give me the odd numbers. Order by that number variable descending, and select number. Now I don't have to select number. I could select number times number or just a constant if I just want a constant value. But in this case, I actually do want to see the number descending and only odd numbers. That fills in the query for me, and I should be able to hover over this and see the results, and they run the query for me and retrieve the results 5, 3, and 1. That's what I expect to see. I have code here that iterates through the collection and writes the output to a string writer, a buffer, and displays the results on the page. If I press F5 and go, we should see the results here in a control on the page. So we've managed to, at this point, coming back into here, we've managed to create a simple query which retrieves the odd numbers from a list of numbers, ordered descending. You've also seen how you generate or how you create this syntax. But let's stop here and look how IntelliSense helps you. Let me try typing it again. odd numbers equals from number, that's my variable, in, and as I type this, obviously it knows what variables are available to me. There's numbers, where, there's my number variable, and of course, this IntelliSense, it's helpful. It could be a little more helpful, I guess, but let's finish this up. Modulus 2 does not equal 0. Order by, there's the syntax of the LINQ statement in the IntelliSense. So order by shows up. Number descending, there's the descending, and so on. So the IntelliSense in C# helps you. It doesn't filter down as much as I might like, but it does help you create the syntax, especially while you're learning it and internalizing how you create LINQ queries. Remember, the two important features here are you can use the var keyword for a variable that contains the query results because there's no way you could guess the query result type. And you put the from clause first so that all the rest of the statements can use IntelliSense to do their work. This is actually the example we were looking at, but you get the point. We've investigated the first language extension that's required for LINQ, that is, writing queries in the language. The next feature that's required is extension methods. Extension methods allow you to add new methods to existing classes. Now, although this is crucial for LINQ, it's not just for LINQ, and you'll see in our example now that we can add our own methods to built-in classes, but this is the basis of working with LINQ internally. They're always defining a class and then later on adding extension methods to it, which might exist in other classes or even other namespaces outside of that class. Extension methods that you create must be declared as public methods. They must accept a parameter, and the parameter they accept must be of the type of the class that you're attempting to extend. For example, if you want to add a method that extends the string class, your method has to accept a parameter which is a string. The method must exist within a static class. It must be a static method, and it must include the this keyword in the parameter. That is, the this keyword will be applied to the parameter that defines the type of the class you're extending. Let's look at a simple example of this. What if you want to add a method to the system.int32 class, an integer? You want to be able to determine if the integer is odd or even. Maybe you want to add an isOdd and an isEven method to the integer class, so you can easily tell if an integer is odd or even without having to write that code every time. You can create an extension method. Now you can call this extension method either as a method of a particular instance or as a method of the class passing a specific instance, whichever one is more convenient for you. In LINQ, you generally call your extension method as a method of an instance of the class. Now it's pretty clear once you look at this why this is required for LINQ. If you think about it, all LINQ is a series of classes with its own methods. But we see it in the language syntax as a where clause or an order by clause. Well, that where clause represents, once it compiles down to IL, it represents a where method on the query class. Let's look at a demo that shows off creating these extension methods. In the last example, you saw that we used the modulus operator to determine if a number was odd or not. And that's fine, but sometimes it would be easier to be able to just extend the behavior of an existing class. This is not only the basis for the entire way that LINQ works, it also makes it possible for you to extend any class you like. So in here, I've added an extension to the integer class so that I can write code like this to determine if a number is odd or not. Where did the isOdd come from? Well, I have here in my project a class named extensions. If we look at the extensions class, first you notice that it is a static class. It has to be for this to work. Also, the isOdd procedure is a static member, and the parameter includes the keyword this. That indicates that it extends whatever data type the parameter is. Since the parameter is an integer, this indicates that we're extending the integer class, the int32 class. And here we return the opposite of the isEven method, and the isEven method actually does the work of comparing the value to see if it's even or not. So by adding this isOdd and isEven extension methods back in the code over here, we can just use isOdd to determine if a number is odd or not. Now, you know the results. It's going to give you the same exact results as last time. But let's stop a second and look at the IntelliSense here. Because we've extended that integer class, as I type here, you'll see isEven and isOdd as methods of the integer class. So by extending it, we've added new methods that look and feel like built-in methods, even though they're not. Now, how does this become part of LINQ? Well, here, for example, this order by keyword. Well, under the covers, that's really a method from the enumerable class which extends the query object. So although the syntax you see here says order by, says where, says select, what we're really doing is calling methods of an object. So for example, we could rewrite this as numbers.where, and you see there's a method. Where is an extension method that extends the array class so that we can use standard LINQ syntax on arrays. At compile time, the compiler converts this where keyword I'm just putting this back the way it was. At compile time, the compiler turns this where clause into a call to the where extension method, which extends the built-in array class and allows us to use this syntax. So although you won't see it unless you look at the compiled intermediate language, fact is, this LINQ syntax converts to a bunch of method calls of extension methods on the array class. Here we've created our own. LINQ uses the built-in ones to provide the same functionality. Of course, you're unlikely to want to iterate over an array of integers very often using LINQ. Most likely, you'll be working with more complex collections, but it's really no more difficult, and this offers some new behavior for us to investigate. In our example, I've created a class named actor. An actor has properties like first name, last name, country, birth date. Very simple class. What if you want to create a new instance of that actor class and provide values for those properties? So what if your class exposes properties but doesn't provide a constructor to initialize them? For example, our actor class. We'd like to create an instance of our actor and add that actor to a collection of actors. Well, there's no new information on this slide. We say actor A equals new actor. Now, I could have used the var keyword rather than the actor type definition there. Either one would have worked fine, and you can see that using the var keyword would not have provided any loss of information, because on the right-hand side of that equal sign, it's pretty clear we're creating a new actor. So why type that name twice? Well, for the word actor, who cares? But for a long type name with a path and a namespace, it would be quite beneficial not to have to type that long name twice. In this case, it doesn't matter. I specify values for each of the properties that I care to specify. In this case, that's all of them. And then add A, our new actor, to our collection of actors. So there's really no new information on this slide. But there's a new way to do it thanks to LINQ. LINQ requires the ability to create objects on the fly and specify values as you create them, and so you get to use that anywhere in the language. Here, we're going to add a new actor to our collection of actors all in one line of code without having to create a new variable for that actor. We say actors.add, new actor, just like you might have done before, except in previous iterations of the language, you couldn't then specify property values at that same time, unless the constructor had that built in. But here we can specify in curly braces, property name equals value, comma, property name equals value, and so on, for each of the properties we'd like to set. If you don't specify the value for a property, then C# assigns that property its default value, an empty string for a string, and a 0 for an integer, and false for booleans, and so on. But once this code runs, we've added a new actor to our collection without creating a separate variable for it, and we've specified values for all the properties of that actor as well. Now, LINQ uses this same technology to allow you to create, as part of a query, a new instance of an object without having to create that object somewhere outside the query, where it really wouldn't make any sense. To demonstrate this new method of creating objects, I'll click the Work with Actors button, and this brings me to an example that demonstrates the behavior. First of all, what does our actor class look like? It's here. It has the properties you'd expect: first name, last name, birth date, and country. And notice that I'm using automatic properties here. You don't need to specify the backing field or the get or the set procedures if all you're doing is exposing a single value. First name is just a string. Just using the get semicolon, set semicolon syntax provides a getter and a setter for that property. It saves a little typing, easier to maintain, and it's a pretty cool new feature in C# in this version. So here we'll walk into the fill actor list procedure. The fill actor list procedure starts by creating a new list of actor, a generic list of actor. Now we'd like to add an actor to the list. The old style, because we don't have a constructor that allows me to do this, is to create the actor first, and then set the various properties of that actor, and then add the actor to the collection of actors. Well, that's one way to do it, but there's an easier way. We can call the add method of the actors collection just passing in the new actor, specifying the properties of the actor at this point. You do it by putting the properties in curly braces, and then you specify property name equals value, comma, for each of the properties you'd like to fill in. Here we'll do it for each of the actors we'd like to add. So we don't need to create a separate step in each case of creating the actor, setting the properties, and then adding it. It's all done in one step. Note also that you don't need to supply all of the properties. This actor doesn't have a country listed. If you don't supply a value, the property gets the default value for the type of the property. In this case, country is a string, so it gets the default value for a string. We'll return this list of actors back, and here in the code that called it, create a LINQ query to retrieve a subset of that list. This should look familiar at this point. We'll name the variable July actors. Note I'm not declaring the type. I don't know the type. I don't have to care about the type. We're working on a list of actors, so this must be something dealing with lists of actors. We'll use actor, the variable, even without declaring its type. They'll figure it out. In the collection, we're iterating through the actors collection where actor.birthdate.month. Remember, birthdate was a property of the actor, so it's just a date time value. We can retrieve its month, where that equals 7. Order by last name, comma first name, so it'll sort first by last name, and if the last names are the same, use a first name field to provide the ordering. We'll select the entire actor object. There we go. And now we'll create a new string writer, loop through our July actors, and for each one, print out first name plus space plus the last name, then birth date, then country in a formatted fashion. And there we go. Had I used a fixed width font, those would have lined up, but I didn't, so they don't. And you see we get the results, each of the actors that was born in July. So in this example, you saw how to use new object initializers to make it easy to create new instances of objects on the fly. We've talked about extension methods in general, but the underlying query class underneath our LINQ query provides a large set of its own extension methods. For example, the all method returns true if everything in the query return value matches some criteria, or any, which returns true if any item in the return set matches a criteria. There's average. There's where, you've already seen. We use the where keyword, but there's a where method which is the result of compiling the code that includes the where keyword. There are a number of different query extension methods, and we'll use some of these as we work through our examples. Basically, anything you want to do with data, the LINQ team thought about and made sure you could do using extension methods of that query class. Now, these methods require some way to indicate the values on which they are to operate. Some of these methods have keywords, like the where keyword, in the query itself, but others don't, like the all query extension. If you want to determine if all members of the return value meet some criteria, you're going to have some way to specify that criteria and the value you'd like to pass as a parameter to test. That requires a lambda expression. A lambda expression is a method you define, the body inside the query, as a simple expression that returns true or false, at least in the all or the any case, indicating whether or not all members of the query match the criteria or any members, and all the other different methods have different syntax. But in each case, you need to have some way to specify the criteria you're testing, and that's where lambda expressions come in. Lambda expressions act as an anonymous method. In each case, you'll supply a single value and the expression return value. If you need more than one expression, well, then you really can't use it right there within the query. You'll need to create a function and call it. But the lambda expression acts as a method that you define on the fly as part of the query itself. The syntax might look something like this. Imagine you've already filled the actors collection with a list of actors and you'd like to iterate through it and display information about each actor. But you only want to do that for actors whose birth date is in September. You might write code like this to do it. You could say for each actor A in actors, of course you could have said var A in actors, either one's fine, but it's actors.where because we're now calling a method of that actors collection, which is based on the query base class, and we need to specify a parameter for that where method. The where method requires a lambda expression which defines the function we want to call for each actor. In this case, I'll refer to each actor as x, and I want to return true if x.birthdate.month equals 9. X here acts as a placeholder for each actor in turn, and the equals greater than implies that we're passing the value into this function. It's a weird syntax. It's new for LINQ, but it allows you to specify the criteria for the where method, which is an extension method on the query base class. Now, of course, we could have done this by taking our actors collection, creating a new query using the where keyword, storing it into a new variable, and then looping through that whole collection. This one just says, I've got my actors collection, let me filter it, and loop through the results of that filter without creating a whole new collection. Let's look at an example that runs this code live so you can prove that it actually works. I'll click the button that runs the demonstration of showing off lambda expressions. We'll start by filling in the actor list just like we did before, and I'll step over that. You've seen that work. We've got a list of actors now, and I'd like to display a list of just the actors that were born in September. So, we step into this, and rather than creating a LINQ query, in this case, I'll use the where extension method. You remember we talked about extension methods before, where the where method actually behaves the same as the where statement in a LINQ query. So actors now is a collection of actor objects, and I'll use the where extension method to indicate that I want to supply a criteria. The way we supply the criteria is indicating a variable, in this case x, and we want to return only those actors where this condition is true, where x.birthdate.month equals 9. So I look at this little symbol, the equals greater than sign, as being like, well, a where statement. I want to return all the actors where this condition is true. I'll use x where x.birthday.month equals 9. You can think of how you want to look at it yourself, but in any case, this represents the individual actor in each case, and since we're looping through a collection of actors, the compiler knows that. And so you even get IntelliSense on X even though we haven't specified its type. X.birthdate.month equals 9 represents the condition on our where clause, and only actors that meet that criteria will be returned. So actors.where, remember this is all one expression, actors.where, and this lambda expression defines which actors get included, will loop through them all and display in the output first name, space, last name, a birth date, and a country. So the only thing we've done different is we didn't actually write a LINQ query. We instead used this extension method where and a lambda expression to retrieve the subset of the actors collection. And you'll see now, if I run at full speed, we only have one actor who was born in September, and because there is no country value, there's nothing inside those parentheses. Lots of different extension methods use lambda expressions, as you saw here. And as you examine the various extension methods, you'll want to think about creating your own lambda expressions to test them out. Every example we've seen so far returns the entire iterator variable as the return value of the select clause. When constructing your query output, you may need to restrict the return fields or even construct new fields. Rather than performing these actions when you use the data, and that would be every time you use the data, you can create a new data type at the moment you retrieve the data. That is, you can create an anonymous type, a type without a name. The syntax looks like this. As part of your select clause, you use the new keyword followed by curly braces. And then you specify the names of the fields you want in the output data structure, in this case name and country. Name is created in this case by combining two other properties of the actor class together, and the country comes across as just the country property of the actor. The syntax involves the word new and the curly braces, and then field name equals value inside those curly braces. Now, we wouldn't be able to retrieve the birth date of an actor if we'd used a query that selected this new data structure, because we haven't included the birth date here. We could retrieve name or country for each actor. Now, under the covers, you're creating here an unnamed type, but the compiler does generate a named type, and you never see what that name is, and they refer to an instance of that named type here. It's called anonymous types because you don't know the name, and to be honest, you don't really care about the name. Let's investigate the demo that shows off this behavior. To demonstrate working with anonymous types, I'll click this sample button, which takes us into code which, again, fills our list of friendly actors. And now I'd like to display a list of actors in the US, but I want to display, as we'll see in a moment, first name, space, last name in a list. And you can do it this way. You can concatenate together first name and last name for each one of them, and that works fine. But you must be asking yourself, can't I do something so that that calculation is performed at the time I retrieve the data? And the answer is, of course, using an anonymous type. To create the anonymous type, you just have select, and not the name of the variable, but a new, and here is code that defines the new type, property equals value, comma, property equals value. This syntax allows you to generate a new type. That is, you're projecting the data onto a new structure, and then when you retrieve the data down here, you can retrieve the name and country properties, and only those properties, because those are the only properties that we've included in the output. Because the compiler knows that, you get IntelliSense as you type, and you get the full name printed out by retrieving the name property of each item. Now, this isn't an actor. A is not an actor. It's some new type. We don't even know the name of the type. Under the covers, the C# compiler generated a name for it. We have no way to know. In this case, you have to use the var keyword unless you create your own type ahead of time, which we didn't do. Since we don't know the name, we have to use the var keyword, and the compiler determines the type for you. In any case, if I run this full speed, you'll see we have here the list we generated manually, and here's the list we generated using the anonymous type. Obviously, the results aren't important. What's important is the technique we used, that is, anonymous types. You'll need to use anonymous types in any case you want to perform a calculation or restrict the output fields from your data. Before we leave the basics of working with LINQ and move on to working with data from a database, I'd like to look at some interesting examples that show off how you can use LINQ in ways that you might not think possible or you may never have considered before. Say you want to retrieve a list of all of the current processes on your computer that are maintaining more than 10 threads. Let's say you want to retrieve a list of all the words in a text file that begin with a vowel. I don't know, these are the kinds of things that programming sometimes needs to have solved. And LINQ makes these kinds of issues easier. That is, any place you need to iterate through and create a subset of a collection of objects, LINQ can come to your rescue. Let's look at the demonstration to see how you can solve each of these issues using LINQ. Let's start by looking at the example that lists running processes for me. Now, there's lots of ways we could do this, but LINQ just makes this a lot easier. What I'd like to do is find all the running processes that have more than 10 threads and then display a subset of the properties of that process. So we'll say var processes, that's our variable that will contain the results of the query, and put in there from proc, that's our variable that iterates through things, in process.getProcesses, that gets me all the processes, where proc.threads.count is greater than 10, so we only want processes with lots of threads, order by threads.count, and if processes have the same number of threads, then by process name, and we're going to select a new type, an anonymous type, which contains process name, working set, and thread count as its properties. For each of those, we'll retrieve properties of the process object. Now, I do want to point out there's another way we can get the same results, and that is using those extension methods that you've seen. I'm not saying this is a better solution, it's just another solution. Sometimes using these extension methods is more convenient or shorter than writing a query. So we could say processes equals process.getProcesses, that's a list of processes, .where we provide a lambda expression which retrieves only those where the thread count is greater than 10, .order by, that's an extension method that allows us to order by, and here you specify the value you want to sort by, .then by allows us to apply a secondary sort. In this case, we want to sort secondarily on the process name. Then we have .select. That extension method acts like the select keyword. This indicates how you want to project the data. What exactly are you selecting? In this case, we pass in this variable proc, and we create a new type, a new anonymous type, which is process name, working set, and thread count using properties of that variable proc. Is this better? Is it faster? It's definitely not faster. It's the same speed under the covers because the compiler converts this pretty much into this anyway. So they're equivalent in processing speed, and we get the results either way. The results come out looking like that, and that's fine. That wasn't the point. What is the point is we get 3 columns with the 3 properties we picked out of each process. Well, that's a pretty cool use of LINQ. There's another example here too. This one is going to attempt to retrieve all the words beginning with a vowel and give me a unique list of those from our text file. Let me go look at that. Here's our text file. It's a list of fake Latin words. And if I want this list of unique words that begin with a vowel, first thing I need to do is get the path. And server.mapPath gets it for us. And I'll walk into the get all words beginning with vowel procedure, which which is here. And this procedure starts by reading all the text from that file. Now, text at this point contains all of the text, obviously. And what we're going to do is take that text and call the split method, passing an array of characters, which indicates the delimiters, that's comma, period, exclamation point, space, and so on. Actually, that's all there is in this case. And we specify the option to remove empty entries. We won't have a bunch of blank entries. Now, we only want the ones where word 0, that is the first character of the word, is a vowel. So we have that here. We'll order by the word, and we'll select the word, and then we'll use the distinct extension method to return just a distinct list of words. So we're combining the two techniques here, taking a query and its output and passing that into a simple extension method, distinct. Well, the return results from that end up back here, and we'll loop through all the words and display the results. And you see we do get a list of unique words from the file that began with a vowel. So should you need that sort of processing, you can see that you can use LINQ to help make that processing simpler. One thing I neglected to mention is, where did that isVowel method come from? You saw here in the query, let's go look at it here, we only wanted words that begin with a vowel. Well, that's over here in our extensions class. There's an isVowel extension method which just returns true if the letter you pass in happens to be a vowel. And so over here in our code, we check the first character and see if it's a vowel or not. We've used that isVowel extension method to simplify this code. Now, I would be remiss if I didn't stop at this point and mention one of the most important features of LINQ, and that is delayed execution. Just because you write a query in the code and the compiler compiles that query, and then at runtime you hit that query in the code, doesn't mean the query actually executes at that point. All the code does is create the query and make it ready to execute. LINQ queries actually don't execute until they absolutely must. For example, if you try to retrieve values, or iterate through the collection, or perform some operation, until you hit a line of code that does one of those things that actually needs the values, no action occurs. This makes it possible for you to create queries in multiple steps. That is, a query that builds upon another query that maybe builds upon another query. And it's not until you actually iterate through the values or retrieve values that LINQ will execute your query.